Hello, my environmental science students. We are going to embark in chapter 12 on air pollution. So if you give me a moment, I will share my screen with you as always. And here we go. So in order to talk about air pollution, we kind of need to talk about what are some of the components that are found in air pollution. So first and foremost, clean air usually consists of nitrogen and oxygen, as well as carbon dioxide and some water vapor. But the most quantity lies with nitrogen. Nitrogen actually makes up some 70% of our atmospheric gas, although we don't use most of it. Our main source of gas is oxygen. A lot of people think that pollution is just man-made, which, a lot of the pollution is human caused. We will look at some of those causes in a little while, but it also occurs naturally as well. For instance, volcanoes. When volcanoes erupt, they spew lots of lava and ash, and that ash comes into the atmosphere and forms air pollution. It mixes with the atmospheric gases, the sulfur, and it forms sulfur dioxide. If it mixes with rain, it can actually form as sulfuric rain or sulfuric acid precipitation. Some other sources of natural pollutants also include dust, pollen, and spores. And on bad allergy days, you've seen when you walk outside how cloudy it looks just in front of you. And I'm not talking about the clouds above you, but in front of you from all the pollen that's in the air. So we do have a little video clip on volcanoes, which we are going to get to right now. And I'm going to share that with you. Bear with me. Okay.
Just look at your tree ring record for the past 500 years and find the fattest ring. Find the biggest, widest, most obvious ring, and that's going to be the year 1816, the year without a summer. Mount Tambora was a stratovolcano that, much like Mount St. Helens in 1980, but at a much greater scale, violently erupted in the year 1815 and caused major destruction of the immediate environment, caused major loss of life.
Nearly 100,000 people were killed in the Indonesian province surrounding Tambora, making it the deadliest eruption in recorded history. So great was the power of this geological phenomenon that for an entire year it altered the world's weather.
A large-scale volcanic emission can get high enough in the atmosphere that it can travel around the globe multiple times.
And all this ash and debris, these clouds get up into the upper portions of the atmosphere, way up there. We're getting 30,000 feet, 40,000 feet. Sometimes it breaks through the stratosphere. And these winds just take all this debris and circle the Earth.
The gas emissions from Tambora blanketed the Earth and choked out the sun's rays. Worldwide crop failure caused global food shortages.
You would have decreases in production of crops because there simply wasn't enough sunlight to grow the crops that were needed to eat.
Major hardships because there was no summer, there was no growing season, there was no crops, there was no food. It was experienced here in the United States as well. This one eruption of a single mountain, a stratovolcano, caused a global cooling event.
That's just one example of how volcanoes can contribute to air pollution. Let's continue with the presentation. So let's talk a little bit about the history. Anytime something burns, that releases a variety of gases into the atmosphere. And as far back as 2,000 years ago, we have records indicating how there were smells of foul air in Rome. The world's air quality problem became much worse today, obviously because of industrial societies. However, it was of an issue, way back in Roman times. The majority of the problems we experience from air pollution is caused by fossil fuels, mainly from motor vehicles and from industries. Almost 1/3 of the air pollution is because of gas being burned by vehicles. According to the United States Department of Transportation, approximately 2.6 trillion miles were driven in 1998. Now this is, you're talking already some 20 years ago almost. So I'm sure that number's a lot higher now. However, your textbook is a little outdated. About 90% of the miles of that 2.6 trillion miles was mainly driven by passenger vehicles. The remainder, those 10%, was actually driven by trucks and buses. In 1970, the Clean Air Act was passed and later strengthened in 1990. And that gave the Environmental Protection Agency, or the EPA, the ability to regulate emissions in vehicles. They required a gradual elimination of lead in gasoline. And as a result, because of that, 90% of lead pollution has been reduced. In addition, something called catalytic converters, which actually help to clean some of the pollutants from the gases before it is exhausted out of the vehicle. These catalytic converters were required in cars in order to help control some of the air pollution. And this is just kind of gives you an idea of what some of an example of what a catalytic converter looks like. The exhaust kind of comes in here, it gets filtered out by a variety of materials, and then when it does get released, it no longer has hydrogen, carbon monoxide, as much carbon monoxide or nitrogen oxide. It still does release some carbon monoxide. The EPA estimates that about 35% of the fuel that's burned today is actually done so more efficiently. We have 95% fewer emissions of pollutants, excluding carbon dioxide, than they did 30 years ago. So when you compare our air pollution today to things that are being emitted today to what was being emitted 30 years ago, you're talking about that there is some improvements, but there's still a long way to go. Many industries, as well as power plants, burn fuel in order to produce energy, and that fuel is usually fossil fuels. As a result, when you burn those fossil fuels, things like sulfur dioxide and nitrogen oxides get released into the air. About 2/3 of all sulfur dioxide and more than 1/3 of all nitrogen oxides are because of power plants producing electricity. Those oxides, that sulfur dioxide and those nitrogen oxides, can actually mix with the water vapor and form acid precipitation. Industries also produce something called VOCs, or volatile organic compounds. And basically, they form toxic fumes. If you've ever painted your room or painted your house, that smell that you get on some of the paints, that's considered a VOC. If you've ever had a smell in your dry cleaning, you picked up your dry cleaning clothes from the cleaners, that smell is a result of VOC. They actually, a lot of cleaners, unless they say that they're environmentally friendly, actually use formaldehyde. And one of the things that you're supposed to do is take the plastic off when you get your dry cleaning home, because it releases a lot of those vapors, so it won't be stuck inside the plastic. Manufacturing plants, oil refineries, furniture refinishers, all release VOCs. Another source of formaldehyde and VOCs are brand new furniture. For instance, I was actually teaching this class a few years ago, and one of my students just bought a new mattress. And she took a look at the label on the mattress, and it said that it was actually treated with formaldehyde. And they do that to preserve the materials in the product that you're buying. But as a result, there's a lot of toxic fumes. Also, too, is lumber liquidators within the last year or two have been under fire because it's been shown that they've been using formaldehyde in high quantities, and it's making people sick. The Clean Air Act also requires many industries to use something called scrubbers to help control pollution. They help to remove some of the harmful substances that would normally pollute the air. And this is just to give you an idea of a scrubber. It uses water spray to move the gases through and dissolve many of the pollutants. So you have your dirty gas coming in, dirty water goes to the bottom, you have clean water coming in, and it kind of gets filtered out so that clean gas actually winds up coming out at the end. So this is a repeat of the slide, I apologize. And we saw that. And we saw that. And we saw that. I think I'm going backwards. I apologize. I was so excited about the material. We just had to do it again. Smog. So when you have pollution and smoke and it mixes with fog, it actually produces something called smog. So basically you have areas, especially like city areas, urban areas, where visibility is reduced because you have all that pollution and it just kind of hangs overhead. It results because of chemical reactions that involve sunlight, air, automobile exhaust, and ozone. And they kind of all mix together and they form this smog. And if you've ever been in a city in the summertime, it's usually very, very evident. You'll hear a lot of the cities say that it's a bad air quality day. And if you've ever walked outside into any of these cities in the summertime when this smog is in place, it really is cloudy. It's disgusting. And it's actually just the pollution. It's not normal atmospheric clouds that we would normally think, but it's actually a cloud of smoke and pollution. Sometimes, especially like with cities, because you have temperatures that are kind of stuck between those buildings and you have those pollutants that are in there, we get something called a temperature inversion. So normally, warm air rises, cool air sinks. But in an area with a temperature inversion, the air above it is usually warmer than the air below. And as a result, any pollutants that are in that cooler area trap pollutants in it, and it makes it very, very difficult to breathe. One of the areas that's very famous for temperature inversions is Los Angeles, because it kind of sits almost like in a dome or in a valley. So they are very prone to temperature inversions. We are going to bypass Bill Nye, the Science Guy pollution solution. You are more than welcome to visit him on your own time and watch that on your own time as well. That is going to conclude the notes for section 1. We are going to go through section 2 in just a few moments. So thank you for joining me, and I hope to see you again in section 2.